Okay. What I want to talk about. Make that a little bigger. I need to get these prepared beforehand. Alright, maybe I can grab this quicker and I can reproduce it. So CD. By golly, that looks like what I want. Okay, so let's copy that stuff to Chico courses. 218, 10, 17. There they are. Okay. I'm going to throw them all into the CPP file. So, read date.h. Stop doing it. Get rid of the header guards. That's the. Okay, so here's a basic date class. We've got the constructor, the display function, the private data. There's the source to the constructor, the source to the display function. We can create a quick main application to run it through its paces. So we say date today is 10/17/2018. Let's make it Independence Day, July 4th, 1776. Dot display. Quickly. Oops, I got one of those. And there it goes, no surprises. All right, so with that as set up, let's go ahead and talk about a conversion constructor. So what constitutes a conversion constructor?
A constructor which takes one parameter.
Very good. Constructor that takes one parameter. So we'll say maybe this takes the year. And then we can say date, colon, date, year, and we will initialize the year with that. Now we have to deal with the month and the day. Let's step it up, not really 511 stuff, closer to 540 stuff, although we don't specifically look at this in 540. How do you get the current date from the system? Anyone know? Programmatically using function calls. Let me come over here. No. If we look at ctime, which is time.h, in C++, we include ctime instead of time.h. Does anyone know the difference between ctime and time.h. My guess is that C time's probably 3 lines. It's probably got 1 line, pound include time.h, and then a third line. The only difference, and there are a number of these, like what's another one? I think C limits instead of limits.h. There are quite a few header files from the C language that they dispense with the .h and put a C in front of it. All they're doing is they're just wrapping a namespace around those functions. Just since they're able to in C++, that gives it a bit of safety from name collisions with your own code. All right. So if we look at this, there is a time function. Where's the time? See also time 3. Unfortunately, if I do that, I get a different man page. I'm not sure how to blow by this one to get the one I want. So, that will give you the current time in seconds since January 1st, 1970. And that can be used with local time. Where's local time? So local time takes a pointer to that information. I think this will work. Let's see, if I do, if I say time t xyz equals, let's do a quick courtesy compile. Okay, everything's still fine. Now looking back at my man page, if I look at that local time function, what you do is you provide the address of a time t variable, so that's my xyz variable. I say local time, and I provide the address of xyz, and what I get back in return is a struct tm, a pointer to a struct tm. So I will create a struct tm pointer, and I will call this the time structure. Now struct tm, if you scroll down here a little ways, they actually show it. There's struct tm. We zoom in. So this structure contains all the information about, in our case, the current time. Note that I don't have to. If I pass in the address of any number, it'll give me this, fill this structure for whatever time that number represents. In this case, I'm getting the current time by passing null in here. So I say time structure equals, and now I can say that the month is equal to time structure, it's a pointer, tm_mon. Note that the month of the year, if you read the wrapping, runs from 0 to 11, so I actually have to add 1 to that. I'll copy paste, the day is equal to, where's the day? Day of month, and that goes from 1 to 31. That's tm_m day. And that should do it. So here's a good example of where the initialization list can't be used because we have to call some functions and so forth in order to initialize our month and day variables. We can test it out. So let's come down here and let me say date today, and we'll pass in 2018 as the year. Should get today's day and month. I forgot to display it. Clear the screen, file, run, and there we go. Okay. calling it implicitly, a good way of doing it, calling it implicitly. So again, it turns a number into a date, yes? And it's called, the word conversion comes in there because it can be used to convert. So for instance, if I have some function and it takes a float, and then when I call this function and I pass in a 3, that works, yes? Because the 3 gets converted into a floating point number. So the concept is the same. Let me create datey date, and this will take a date, dt. And in here, well, let's call it arg. And in here, we will pass in, or we will say arg.display. Now to this function, we're going to call it, and we'll say date, and I will pass in 1999. So we have no datey-date function that takes an integer. We have one that takes a date. But the conversion constructor will convert 1999 to a date. So I come here, I compile, I run, and there we go. Yeah.
So when you pass in the it calls the constructor which takes the int of the arg and it constructs the arg using that conversion constructor.
That's correct. Arg is created using the conversion constructor. Yeah. We can go the other direction as well. That would be the conversion operator. And so we'd say operator, and then you specify the kind of thing that date is going to turn into. We want to turn date into an integer. There's no return type specified here. In fact, it won't compile if you try to specify a return type. By definition, int is returned from this function. It is a member function, so I have to say date : operator int. And what we do is we can return, like we can return the year. So I can create the complement to this function. We'll call this int, and it takes an integer, arg, and we can just say cout the number equals arg. Oops. int, and we'll pass in a date. We'll pass in IND. So that is allowing you to go back and forth. This kind of syntax goes, so this gets to operator overloading. You can create member functions for the vast majority of operators out there. So I can create operator plus, which would look something like that. I won't actually define it, but to call it, you would say something like dt plus dt2. You'd take two date objects and it would call that. And an alternative syntax would be dt dot operator plus. This would be kind of easier on our eyes. Right? When you do line 17, its invocation is actually exactly the same as line 18. That's what's happening. That operator is a member function, so you can invoke it like a member function. Both of those will compile just fine. Not all operators, so the operators are sometimes customized and repurposed. Does anyone know what the original purpose of the chevron was?
It shifts.
Yeah, so that would shift the bits in A 2 positions to the left, right? Or go in the other direction, it would shift them 2 positions to the right. So that operator has been repurposed to serve as our input and output. Let's experiment with what that actually is doing. Actually, before we do that, let's look on the web at operator Chevron. Let's see what that pulls up for us. Host string. Let's just go with host string. Okay. So if I look through OStream here, we find that here's a member function of the OStream class right here, the operator less than, and you can see they've actually written quite a few of those operators to handle all these different types. So let's go ahead and try that. We can say cout, print out 3.14. We can print out letter A. We can print out, what else? Something else we can print out. An integer, 99. And how about howdy? Like that. Okay. Whoops. I need to comment that out. So there's no surprises there. But what is the alternative syntax for calling this then? Actually, let me start with a different question. All of these return an O stream. What does that mean? Why is it returning an O stream?
It's the same as when we did the exception handling project. We returned dereference this. So we returned a reference to the object, which was pointing to refer to the calling object.
That's exactly right. So you can imagine class OStream, and in their public area they have this operator Chevron that takes an integer, and then if we were to bust open the code for that, let's see what I want to do here. Then it would do stuff to output arg, and then the last thing it would do is it would return this. Oops. All right, so it's a member function. So why is it returning itself?
I remember the example that we did with chaining assignment operators. Perhaps as we're chaining, we're passing it multiple values into the cout. So
right. So cout dot operator. Oh, let me undo this. Let me copy and paste that. And so let's create an alternative call of this. Cout dot operator Chevron. So the result of that function call is cout, right? Since cout is sitting there, then we can call operator Chevron that. Now we're going to have to make modifications to this, but let's try it first. So, oops, I forgot the operator. So that might be what it looks like. Now, if we look at this carefully, though, let me go ahead and run this, see if it even compiles. It's probably not going to compile. All right. So it has a problem with some of these. Let's start debugging it. Let me put a semicolon there and comment the rest out. Let's see if we can get 3.14 printing at least. Oh, I've got different problems because I was doing this stuff here. All right. Let me come back here. Let's see if we can repeat this process somewhere that along the lines that shouldn't compile. But note that line 73 is not the same as line 76. In particular, note that we're getting some funky string here instead of, we're getting an address there instead of the string howdy. We are also getting 97 instead of a lowercase a, which is the ASCII value of a. So this isn't working quite the way we expected. Let's take a closer look here, and we can see that so it doesn't like the character A, and it doesn't like the string howdy. That in essence is a character pointer.
And the address of the first character is what being displayed, correct? Address of the agent.
Yes, the address of the first character of that. And if you look here, there is no character pointer, and there is no character. Those are two that don't exist as member functions here. So something different is happening. But it works. Why is it compiling and working? Well, what happens to this? Right, it turns into one of the numbers, so maybe it goes into here. Right? And the same for howdy would work in this void pointer here, and that's just printing out the address of that pointer. Okay, so those are the functions that are getting called. If I look down a bit, let's see. See also, so let's see this. Okay, note these take two arguments. These are not member functions. These are normal C-style functions. So if I come back to here and I look at this code that I've done, let's create what the equivalent would look like for this function were it not a member function. It still returns an OStream reference. It's still called operator Chevron, but now it takes two arguments. So it's going to, like line 61, it's going to do stuff, and then what does the return statement look like? It is. That's exactly right. It's returning OS, right? And so this version, where I say cout less than arg, is the same as saying operator Chevron cout arg, right? It's called like a normal function. Okay, so looking at this, there's the character. The character is called in this way, and so is a character pointer. So these are the two, they're non-member functions that print out the character in the string. Now I can simulate that. So now let's trick up our simulation here. Let me comment that out. Come down here. Printing a float is fine, but this character has to be printed out like a normal function. So okay, so ignore that stuff down there. Here's the normal function. First,
global function.
Yeah, it's a global function. Here's the first call to cout as a member function for 3.14. That returns cout. Then it becomes the first argument to this two-argument function with a being the second one. Next we have the 99. Since this normal function returns C out, then that works to call it as a member function. But then this whole thing is the first argument and goes right here. Put a comma, right? All that stuff goes right there. So now I take this, I paste that in there. What I'll do is I'll add a few spaces. Let me zoom in. And there you go. So that is what the compiler produces.
Cool.
Two normal calls and two member function calls. So let's try it, confirm that our output now looks the same. I screwed something up somewhere. Probably have parentheses mismatch. Oh, that looks fine.
About above. Do we have like an extra function definition above?
Oh, yeah, I keep messing around with this stuff up here. All right, let's try it again. And there we go, same output. Okay. So, what about date? Printing out the date, this is what I like to call, that's 111 cool right there, printing out the date. Let's make it 511 cool. Right, 511 cool is to print out the date the same way you'd print out an integer. So we have to write an operator, insertion operator, the left chevrons. Can it be a member function? So here's the first question. Can it be a member function of the date class? The answer is no, but the question is why can it not be a member function? What does, and let's again look at, let's see if I have a commented out example here. I can do this right here. Here's an example of calling the plus operator as a member function. If it wasn't a member function, I would call it something like this. If it's a member function, look at lines 17 and 18. What is true 100% of the time? Yes?
The left object is the calling object, and the right object is the parameter.
The left object is the calling object, right? Line 17 turns into line 18. dt is what invokes that operator plus. Think about output now. Cout. What is the left object? It's an O stream. We can't get in there and manipulate O stream. There's no way that I'm going to be able to have something like this where I'm passing in a date, right? So my only choice is to have a non-member function to output the date. So let's go ahead and write it. I'll put it right here. I'll say, what is it going to, so it's going to be operator, Chevron that way. It's going to take an O stream reference, and on the right will be const date reference, right hand side. So constant reference. Let's see if we have any good examples here. Well, I'll get to that. I'll have to get back to that. What does it return?
O stream comparison.
All right, so give me the output. Let's output a date. Here, let me show you the display function for reference. Where is it? What I'll do is I'll take lines 46 through 50 and delete them, and I'll just move them up higher so that we can look at them. All right, so there's the original output. What does it look like here? OS.
Yeah.
Exactly. Yeah. Slash. What do you think?
I think that function call is actually calling multiple functions.
Well, yeah, it is calling multiple functions, but I'm not concerned about that. So my question is, do I want end line there? We can do it syntactically, but I'm asking philosophically, and we're going to return OS. Ah, you want the user to be able to decide that. Exactly. When I create integer x and I see out x, it's not printing an end line for me. If we want an end line, we print it ourselves, right? Same with date. We want it to print out the date and nothing else, and if they want an end line, they'll add it. Let me get rid of that. All right, but this isn't going to quite compile yet. Let's see why. So we'll say cout less than let's say independence equals ind end line. Okay. What's it complaining about? We don't have access to the private data. So that's one possibility, is you can create getters. There's a more graceful way of doing that, and that is to have the date class tell the world, or tell the compiler, I guess, that this function, this ordinary function, is a friend and has permission to look at the private data. So you just take the function declaration, I'll put a semicolon there, and you put the word friend in front of it. So this is telling the compiler that this function is able to access the private data of any date object. Okay. Now, where you put it in this declaration doesn't matter. I can have it right here. I can have it in the public. I can have it before either one of these. It transcends the meaning of public and private. It's just information for the compiler. Yeah?
You don't have that semicolon?
No. It looks exactly, so it's like putting the word virtual in front of it, right? It's just another keyword in front of the function declaration. I would put it in the public area. Now I come here, I try compiling, and now it's happy. Okay, so there's that. Now we are able to use our dates much more naturally. Let's see, I want to make sure I'm not missing anything. All right, so in the final few minutes then, let's talk about what I'm looking for you to do before Friday. So this is going to be due, I have the due date like noon on Friday, so just an hour before class is when this thing's due, so you have just shy of 48 hours. Oh, that's fine, I can skip that. So looking at this Project 3 stamping press, there is this little mini assignment. We had the same kind of thing, a couple small preliminary assignments before the project due date for the exception handling. Same thing for this project. You have to write, so these things that sit inside of an input or an output stream are called mutators because they mutate the state of the output machinery. Change it somehow. This mutator, it takes two arguments. You give it a character and a number, and wherever that appears, it will print, in this example, it'll print out 80 hyphens. Okay. There's a way to do it that I don't want you to do it, is you can simply write a function that takes a character and a count. You can create a for loop to build up a string, and then you just return the string. and then cout just prints the string that is returned by this. Okay? Don't do it that way. What you have to do instead is you have to create a class called repeat, and you have to write an insertion operator to output a repeat object. So the repeat class is going, this right here is actually constructing a repeat object. That's a 2-argument constructor to the repeat class. What your repeat class should have is it should have 2 pieces of private data, a character to hold the hyphen and then an integer to hold that count. Okay? Then you're going to write the Chevron operator here. It needs to be a friend of the repeat class because it's going to access the private data of the repeat class, and it's going to access that character and that number. And this operator is going to have code that kind of looks like this, except instead of building a string, it'll be OS Chevron CH. Count times. Does this make sense? So that is what I need you to do then in the next 48 hours. Okay. All right, then we will stop it here and we will see you on Friday. Yeah.
Can you go back to the code? So I would like to see the yeah. So we have the member function of the OStream class, which is the operator, and it returns the OStream by reference. And in the return statement, we do dereference this. Dereference this. Dereference is to get the object.
Correct.
But whether we return by value or by reference is mandated by the return type.
That's correct.
If we would remove that reference, it would call the copy constructor.
If we removed that, then it would create a copy of the invoking object, yes. Yep. All right.